Okay, let's unpack a topic that's really reshaping the business world right now.
Yeah.
How integrating machine learning with platforms like UiPath is transforming how companies get things done, end to end.
Yeah, it's a fascinating area. And for this deep dive, we're focusing our insights based on a specific piece of research, a recent study that sort of lays out the current landscape of this AI-powered automation.
Right, and our mission here is pretty clear, isn't it? We want to dig into the study, pull out the key insights, really get our heads around the why and the how of this integration.
Exactly, and explore what it actually means for businesses, large and small, and honestly, for how we all approach work these days.
The study we're looking at, for context, was published in the International Journal of Science and Research Archive. It just came out, February 2025.
Hmm.
And it's titled Optimizing End-to-End Business Processes by Integrating Machine Learning Models with UiPath for Predictive Analytics and Decision Automation. The authors are Ramakrishna Debbadi and Obid Boateng. So, yeah, it's a fresh perspective.
It is.
Yeah.
And we're using that study as our guide, really, looking at the core role ML plays when you bring it into traditional automation, like RPA. UiPath is the main example here,
A
obviously.
leading platform in the space.
Absolutely. So we'll dissect the benefits, things like predictive analytics, actually automating decisions, which is a big step up from just tasks. We'll also look at the real-world challenges, because it's not always straightforward,
Never is.
and the future potential, all through the lens of what this particular research found.
And why should you, listening right now, care about this? Well, because this intelligent automation, it's not some sci-fi concept anymore. It's genuinely changing how companies operate.
It really is. It affects processes behind the scenes, things like invoice processing, but also directly impacts how companies interact with you, the customer.
So understanding this ML integration, it gives you a shortcut, really, to grasping a key trend that's, well, touching pretty much every industry out there.
Couldn't agree more. And think about the journey automation has taken. It's important context. We started with something much simpler, right? Rule-based automation. What most people know is RPA, robotic process automation.
The bots that just click buttons and fill forms, basically.
Pretty much. And look, it was effective for automating repetitive, predictable tasks. Things that followed a very clear, predefined set of rules, like digital workers doing the same thing over and over.
Okay, so good for the simple, static stuff.
Exactly. Static is the key word. But as the study points out, it had some pretty significant limitations. It really struggled to adapt when things changed. Dynamic environments, not its forte.
If the input looked different or the website changed slightly.
It often fell over, yeah. And it needed constant updates. Anytime the rules needed tweaking, maybe to handle a new exception or a change in the process, someone had to manually go in and update the bot script.
Sounds like it worked well inside its box, but anything outside that box caused problems.
That's a good way to put it. The real turning point, the game changer highlighted in the research, was bringing in AI, and specifically machine learning.
Right.
This allowed systems to move beyond just rigid rules. Suddenly, they could learn from data, huge amounts of data, identify patterns, predict trends, and crucially, make autonomous decisions based on that learning.
So we went from bots that just followed orders to bots that could actually learn from experience and decide what to do next.
That's the fundamental shift. It moves us into what the study calls modern AI-driven automation. And this goes way beyond simple rules. It incorporates technologies like natural language processing, NLP, letting bots understand human language.
Like reading emails or chat messages.
Exactly. And predictive analytics for forecasting, anomaly detection for spotting unusual things. It opens the door to automating much more complex tasks, tasks that traditional RPA just couldn't touch.
What kind of complex tasks are we talking about?
Well, the study gives examples like sophisticated fraud detection. Instead of just checking simple rules, ML models can analyze complex behavioral patterns over time.
Ah, looking for subtle signs of fraud.
Precisely. Or understanding customer sentiment. Not just reading the words in an email, but figuring out if the customer is happy or angry.
That requires understanding nuance.
It does. And another big one is intelligent document processing. Systems that can read and understand documents like invoices or contracts, even if they don't follow a strict template. Things that used to require human judgment or interpretation.
Okay, so ML is bridging that gap.
It is. And according to the study, this integration leads to real benefits. Faster response times, better accuracy, improved compliance, reduced operational risks. It's the synergy between AI, ML, and platforms like UiPath that's driving this next wave of efficiency.
Okay, so ML is clearly the star player here. Let's break down what ML actually is and its specific role in making automation smarter.
Right. So machine learning, it's a subset of artificial intelligence. The simplest way to think about it is enabling computers to learn from data without being explicitly programmed for every single scenario.
Instead of writing code for every possibility, you feed it examples.
That's the core idea. You provide data, and the system learns the underlying patterns and relationships itself. Then it uses that learning to make predictions or decisions on new, unseen data.
So it generalizes from the examples.
Exactly. And when you apply this learning capability to RPA, it's incredibly powerful. It lets the automation systems break free from those static, rigid rules we talked about. They can adapt in real time based on the operational data they're seeing.
So that's where the adaptability comes from. It learns as it goes, in a sense.
Precisely. And probably the most significant advantage ML brings, as highlighted in the research, is predictive analytics.
Looking into the future, basically.
Kind of, yeah. The system analyzes current and historical data to forecast trends, identify potential anomalies, things that look out of place, and enable proactive decisions. You can see potential issues before they actually cause problems.
That proactive element sounds like a huge deal for businesses, moving from fighting fires to preventing them.
It really is. The study offers great examples. In finance, ML-powered automation can predict potentially fraudulent transactions by looking at complex patterns, way beyond simple rule checks.
Catching things humans might miss.
Or catching them much earlier. In customer service, ML lets chatbots analyze past interactions and customer data to personalize responses, make the conversation feel more relevant and helpful.
So the bot kind of remembers you and tailors the conversation.
Essentially, yes. It learns preferences and patterns. These ML models, integrated into platforms like UiPath, use various learning techniques. They can classify complex data like text or images, automate document processing much more accurately, and crucially, they keep improving. They learn from the new data they process.
That continuous learning is key. You mentioned reinforcement learning earlier. Is that the trial and error part?
Yes, that's reinforcement learning. It's a type where the system learns the best course of action by trying things out and getting feedback rewards or penalties within its environment. It's really useful for optimizing processes where the best path isn't obvious up front.
Like figuring out the most efficient way to route a complex task.
Exactly. The system explores and learns the optimal strategy over time. Overall, the study emphasizes that integrating ML leads to tangible benefits: lower operational costs, enhanced accuracy, better compliance, and the ability to scale automation to much more complex cognitive tasks.
It really does sound like giving the automation systems a brain, allowing them to think and learn, not just execute commands.
That's a good analogy. Now, the study does touch on some core ML concepts. We don't need a super deep dive into the math, but understanding the main types of learning helps clarify what these systems can actually do.
Okay, let's keep it high level. What are the main categories?
The first one is supervised learning. Think of it like learning with a teacher providing the answers. You give the ML model data that's already labeled.
Labeled, meaning you tell it what the right answer is for each example.
Exactly. You show it pictures of cats and dogs, and you label them cat or dog, or you show it transactions and label them fraudulent or not fraudulent. The model learns the mapping between the input data and the correct output label.
Okay, so it learns from known examples. What's that used for in automation?
Things like classifying documents. Is this an invoice or a contract? Detecting known types of fraud. Segmenting customers based on predefined categories. Predictive maintenance, where you have historical data on failures.
Got it. Learning from examples with answers. What's next?
Then there's unsupervised learning. This is more like exploration, learning without a teacher. You give the model data without any predefined labels or answers.
So what does it do?
Its job is to find hidden patterns, structures, or relationships within the data all on its own. It might group similar data points together, for instance.
Finding clusters. Like grouping customers with similar buying habits, even if you didn't know those groups existed.
Precisely. Or detecting anomalies, identifying data points that look significantly different from the rest, which could indicate fraud, errors, or system issues, even if it's a pattern you've never seen before.
Finding the weird stuff, basically.
That's a good way to put it. It's great for discovery and finding unexpected insights. Finally, reinforcement learning, which we mentioned. This is about learning through interaction and feedback, trial and error.
Learning by doing and seeing what works.
Right. Learning the best sequence of actions to achieve a goal in a dynamic environment, like optimizing a complex workflow or controlling a robotic arm.
Okay, supervised, unsupervised, reinforcement. Got the basic ideas. The study also mentioned feature selection.
Yes, feature selection is crucial. It's about choosing the most relevant pieces of information or features from your data to feed into the model. Using irrelevant data can confuse the model or slow down training.
Focusing the AI on what actually matters.
Exactly. And then there's model training itself. This involves feeding the selected data to the chosen algorithm, letting it learn the patterns, and then rigorously evaluating its performance using metrics like accuracy, precision, recall, making sure it works well on new data it hasn't seen before.
Testing it to make sure it didn't just memorize the training examples.
Right, ensuring it can generalize. This involves techniques like cross-validation and hyperparameter tuning, tweaking the model's settings for optimal performance.
So simplifying. Learning with answers, supervised, finding patterns alone, unsupervised, learning by doing, reinforcement, picking the right data, feature selection, and then training and testing properly.
That captures the essence relevant for automation. And this brings us right back to why ML became so essential. What were those key limitations of traditional RPA that drove this evolution?
Right, the pain points that ML addresses. Let's really emphasize those drawbacks of the old rule-based approach.
The study is very clear on this. The number one issue was that reliance on static workflows. Traditional RPA bots were brittle. They were built for specific, unchanging processes.
If anything changed in the application, the data format, the process steps.
The bot would likely break, yeah.
Yeah.
It lacked adaptability. Dynamic business conditions, slight variations in input data, these were major challenges.
That rigidity sounds like a huge bottleneck.
It was. And they struggled massively with unstructured data. Think about the text in an email, a scanned PDF invoice where the layout isn't perfect, a customer support chat message. Traditional RPA just couldn't reliably extract information or understand the meaning from that kind of data.
It needed everything perfectly structured and predictable.
Exactly. Which meant humans often had to step in to handle exceptions or pre-process the data, kind of defeating the purpose of full automation sometimes.
Right, which also leads to the maintenance issue you mentioned.
Absolutely. High maintenance costs were another major drawback, according to the research. Because everything was rule-based. Every time a business process changed or a regulation was updated, someone had to manually go in and rewrite the bot's script.
Constant tinkering just to keep the automation running?
Yes. And imagine doing that in highly regulated industries like finance or healthcare, where rules and compliance requirements change frequently.
Yeah.
It becomes a significant operational burden.
Definitely. What else?
They were also inefficient for complex processes, tasks that required more than just following simple sequential steps. Traditional RPA couldn't analyze historical trends to make predictions or optimize decisions based on data.
Like the sophisticated fraud detection or demand forecasting examples.
Exactly. Rule-based systems couldn't perform that kind of analysis. They were purely reactive, executing predefined instructions based on simple criteria. They couldn't learn or anticipate.
Okay, so the old way was rigid, struggled with messy data, needed constant updates, and couldn't handle complex, data-driven decisions. That sets the stage nicely for ML.
It really does. Now, let's contrast that directly with the benefits of ML-driven predictive analytics, really expanding on what the study highlights.
Let's really hammer home how this flips the script.
The biggest shift is enabling proactive decision-making. By analyzing patterns and forecasting outcomes, the ML integrated automation can anticipate potential issues or opportunities before they happen.
That changes the game from fixing problems after the fact to actually preventing them.
Fundamentally, the study gives great examples. In supply chains, ML can predict demand surges much more accurately than simple historical averages. UiPath bots can then use these predictions to automatically adjust inventory orders, preventing stockouts or minimizing excess stock.
So the system is thinking ahead, optimizing based on anticipated needs.
That's the core idea. In customer service, predictive analytics can anticipate why a customer might be contacting support based on their history or recent activity. The bot can then proactively offer relevant information or solutions, making the interaction faster and more effective.
Like guessing your question before you even fully ask it.
Kind of, yeah, based on context and data. Another major benefit is vastly improved accuracy and reduced need for human intervention in many decision-making tasks. ML models learn and refine their predictions over time, becoming more accurate than static rules, especially for complex scenarios.
So fewer errors slip through and fewer routine checks are needed by people.
Exactly. The study points to financial risk assessment. ML models can analyze far more variables and complex relationships than a human or a simple rule set, leading to more precise loan recommendations or risk scores, reducing defaults and freeing up underwriters' time,
More accurate decisions, less manual effort.
which drives process efficiency. By automating decisions that previously required human judgment based on the ML model's predictions, you minimize bottlenecks and unnecessary manual oversight.
Like the example in the study about healthcare predicting patient no-shows to optimize scheduling.
Exactly. That's a perfect example of using prediction to improve resource utilization and efficiency. By moving to ML-driven predictive analytics, organizations shift from workflows that just execute steps to intelligent systems that anticipate, analyze, adapt, and learn.
Automation that actually gets smarter over time as it sees more data.
That's the promise. And the study backs this up not just with theory, but with specific case studies showing these benefits in action.
Okay, let's dig into those real-world examples from the source. Tell us about that ML-enhanced document processing in finance.
Right, this involved a major global bank using UiPath integrated with AI for invoice and contract processing. This is a classic pain point, right?
Yeah.
Documents arrive at all sorts of formats, making traditional template-based automation really difficult.
Because every vendor's invoice looks slightly different, different layouts.
Exactly. Standard OCR, optical character recognition, often wasn't enough or was too brittle. But by integrating ML models trained on a wide variety of document examples, the automation could intelligently understand and extract the key information.
Not just reading characters, but understanding this is the invoice number, this is the total amount, regardless of position.
That's the core capability. The ML model learns the context and the typical patterns for different data fields. The results reported in the study for this bank were pretty impressive. A 60% reduction in processing time
Wow, cutting processing time by more than half.
and a 35% reduction in error rates compared to their previous methods. Huge operational improvements just by making the document understanding intelligent.
That really quantifies the impact. What about the predictive maintenance example?
This was a large manufacturer. They used UiPath workflows connected to ML models analyzing real-time sensor data from their factory machinery, things like temperature, vibration, energy usage.
Okay.
Traditionally, maintenance was often scheduled based on fixed intervals, like service every 1,000 hours, but that's often inefficient, either too early, wasting resources, or too late, leading to unexpected breakdowns.
Which can shut down a whole production line, very costly.
Hugely costly. So the ML system analyzed the patterns in the sensor data, learning the subtle signs that often precede a failure. It could then predict potential equipment issues before they occurred.
Giving them advance warning.
Exactly. This allowed them to schedule maintenance proactively, right when it was needed, optimizing resource allocation and preventing those costly unplanned downtimes. The result cited was a 45% reduction in equipment downtime.
Almost cutting breakdowns in half. That's a direct hit to the bottom line.
Absolutely. Then there's the customer service case study, an e-commerce company using ML-driven sentiment analysis. The problem with older chatbots, as we know, is they often sound robotic and can't grasp the customer's actual emotional state.
Right, you could be furious, and it gives you a standard, unhelpful answer.
Precisely. By integrating ML-based NLP and sentiment analysis, the new system could detect the emotion behind the customer's words: angry, confused, happy, frustrated.
So it could tell how the customer was feeling.
Yes. And this allowed the automated system to adapt its response. Maybe immediately escalate an angry customer to a human agent, or offer a specific solution to a confused one. The results were significant. A 30% increase in customer satisfaction scores,
Happier customers, that's key.
and a 40% reduction in escalations to human agents, freeing up the support team for more complex issues. Another clear win-win.
Definitely. And the last one was fraud detection.
Yes, in banking. A major financial institution used UiPath integrated with ML anomaly detection models for real-time transaction monitoring. Traditional rule-based systems often miss new or sophisticated fraud tactics because fraudsters constantly adapt.
They learn how to get around the simple rules.
They do. But the ML system learned from vast amounts of historical transaction data, identifying subtle patterns and anomalies that indicated suspicious activity, even if it didn't trigger a specific predefined rule.
Finding the needles in the haystack. Essentially, yes. The system achieved an 85% accuracy rate in identifying suspicious activity, leading to a reported 50% reduction in successful fraudulent transactions, minimizing financial losses.
These case studies really drive home the point.
Yeah.
This isn't just theory. It's delivering measurable, significant business results right now across different areas.
They really demonstrate the tangible value proposition. Which leads us naturally to the practical side. How do you actually get these ML models integrated into a platform like UiPath and make them work in a real process?
Okay, let's walk through the nuts and bolts. How does UiPath enable this integration?
Well, the study emphasizes that UiPath isn't just a basic RPA tool anymore. It's been developed specifically to incorporate these AI-driven capabilities. It supports various ML models for tasks like document understanding, process mining, which is analyzing how your processes actually run to find bottlenecks and predictive analysis.
Well, it has built-in features specifically for AI and ML. Yes. A key component highlighted is the UiPath AI Center. Think of this as a central hub within the UiPath platform designed specifically for managing the AML lifecycle.
What does it let you do?
It provides an environment where organizations can train their own ML models, deploy models trained elsewhere, manage different versions of models, and crucially, make them easily consumable by the UiPath robots in their automation workflows.
So AI Center acts as the bridge, connecting the ML intelligence to the automation execution.
That's a great way to think about it. Now, before you even get to deployment, a critical first step, according to the research, is identifying the right use cases. Where will ML actually add significant value?
Right, you don't just sprinkle ML everywhere. How do you figure out where it fits best?
The study suggests looking for processes that currently rely heavily on human judgment, deal with a lot of unstructured data, or require predictions or dynamic decision-making that goes beyond simple rules. Good candidates often include things like fraud detection, complex document processing like invoices or contracts with variable formats, customer support interactions where understanding intent or sentiment is key, or maybe predicting delays in a supply chain. If a process feels too complex or variable for simple rules, ML might be a good fit.
Anywhere a human is currently looking at messy data, finding patterns, or making predictions.
That's a good rule of thumb. And once you have a potential use case, the absolute most critical ingredient stressed repeatedly in the study is data.
Data, data, data. It always comes back to data with ML, doesn't it?
Always. It's the fuel. The accuracy and reliability of your ML model depend entirely on the quality and relevance of the data you train it on. This data can come from various sources, structured databases, ERP systems, CRMs, but also unstructured sources like emails, logs, images, text files.
So first step is gathering all that relevant information together.
Yes. And then comes a step what the study calls absolutely essential: data preprocessing. Real-world data is almost never perfect. It's often inconsistent, has missing values, contains errors or noise, uses different formats.
It's messy.
Very messy. So you have to clean it, standardize it, handle missing entries appropriately, remove duplicates, normalize values, basically get it into a consistent, high-quality state that the ML model can actually learn from effectively.
That sounds like potentially a lot of work up front.
It often is, but it's non-negotiable. The study also mentions feature engineering, selecting the most predictive data attributes, and sometimes transforming them, like combining fields or creating ratios, to make it easier for the model to learn useful patterns.
Helping the AI focus on the important signals in the data.
Exactly. And finally, data splitting. You need to divide your prepared data into separate sets. Typically a training set, the bulk of the data used to teach the model, a validation set used to tune the model's parameters during development, and a test set, kept completely separate and used only at the end to get an unbiased estimate of how well the model performs on new, unseen data.
So you train it on one part, tweak it on another, and test it on a third, completely fresh part.
That's the standard practice for building robust models. The study explicitly warns, and it's worth repeating, poor data quality directly leads to inaccurate predictions, biased decisions, and automation failures. Garbage in, garbage out is the absolute rule here.
Got it. Data quality is paramount. So assuming we've got our clean data and a trained model, how does it actually get plugged into a UiPath workflow?
The study outlines a few primary methods. Step one is model selection and training we just touched on, picking the right algorithm for your task, and training it using standard ML frameworks like Python libraries, TensorFlow, scikit-learn, etc. Then packaging the trained model for deployment.
Okay, you've got your trained AI brain ready to go.
Step two often involves API-based deployment. This is very common. You host your trained ML model on a dedicated platform, maybe a cloud service like Azure ML, AWS SageMaker, or Google AI platform, or even an internal server. These platforms expose your model through an API.
An API like a web address the UiPath bot can send data to.
Essentially, yes. It's a standardized way for software components to communicate. Your UiPath workflow uses a specific activity, like the HTTP request activity, to package the input data, send it to the model's API endpoint, and then receive the prediction back from the model.
So the UiPath bot calls out to the ML model, gets the answer, and brings it back into the workflow.
That's the flow. It leverages the specialized infrastructure, often in the cloud, for running the computationally intensive ML model. Step 3 is using the UiPath AI Center, which the study highlights as a more native integration option.
How did that differ from the API approach?
With AI Center, you can upload your trained ML models directly into the UiPath environment itself. You configure endpoints within AI Center, and then your UiPath robots can call these models directly using dedicated AI Center activities without needing to make external API calls to cloud platforms.
So it potentially simplifies the integration and keeps things more within the UiPath ecosystem.
Yes, it's designed for tighter, more seamless integration, managing the models alongside your automation projects. Step 4 is automating decisions based on the model's output. This is where the magic happens in the workflow.
Using the prediction to drive the next step.
Exactly. Based on the prediction received from the ML model, say a high probability score for fraud, or extracted data from a document with high confidence, the UiPath bot executes specific actions. It might route the case for human review, automatically approve a low-risk transaction, update a system with the extracted data, send an alert. The possibilities depend on the process.
The ML provides the insight, the bot takes the appropriate action. The study conceptually showed a figure illustrating this workflow, right?
Yes, visualizing that flow. Data input, take ML model prediction via API or AI Center, dates UiPath bot action.
Makes sense. So once it's up and running, how do you ensure the ML part is actually working well and stays effective over time? Evaluation must be key.
Absolutely critical. The study stresses that evaluation isn't a one-off check at the end of development. It's an ongoing process vital for long-term success and trust in the system.
What kind of metrics do you track? How do you measure performance?
It depends heavily on the type of ML task, as the study explains. For classification tasks like deciding fraud versus not fraud, or categorizing documents, key metrics are accuracy and precision. Accuracy is the overall percentage of correct predictions.
How often it gets it right in general?
Yes. Precision is about minimizing false positives. Of all the times the model predicted fraud, what proportion were actually fraudulent? High precision means when it flags something, it's likely correct.
So you don't waste time investigating things that aren't actually problems.
Exactly. Then there's recall, which is about minimizing false negatives, making sure you catch as many of the actual positive cases as possible. Of all the truly fraudulent transactions, how many did the model successfully identify? High recall is crucial when missing a case is costly or dangerous.
Like in medical diagnosis or critical alerts?
Precisely. And the F1 score is often used, which is a combined measure that balances precision and recall. For anomaly detection tasks, these metrics are also very relevant.
Okay, that covers classification. What about predictions of numbers?
For regression tasks, where the model predicts a continuous value like forecasting sales, predicting processing time, or estimating financial risk score, different metrics are used. The study mentions MAE, mean absolute error, and RMSE, root mean squared error. These essentially measure the average difference between the model's predictions and the actual values. Lower error values mean better predictive accuracy.
How close were the model's guesses to the real outcomes?
That's the idea. The study also highlights the value of the confusion matrix for classification tasks. It's a simple table that breaks down the predictions, showing true positives, true negatives, false positives, and false negatives. It gives you a clear visual picture of where the model is succeeding and where it's making mistakes.
Like a detailed report card for the model's performance.
It's very useful for diagnosing specific types of errors, and a really crucial concept for ongoing monitoring is model drift detection.
Drift? What does that mean?
ML models are trained on data from a particular period, but the real world isn't static. Customer behavior changes, market conditions shift, new types of fraud emerge. The patterns in the data can change over time. Model drift occurs when the model's performance degrades because the new, live data it's seeing is significantly different from the data it was trained on.
So the model that was accurate 6 months ago might become less accurate today because the world changed.
Exactly. Detecting this drift is vital, so you know when the model needs to be retrained or updated with more recent data to maintain its effectiveness.
That makes ongoing monitoring essential. What strategies does the study suggest for this continuous improvement?
Several key strategies. Automated data pipeline updates are important. Setting up systems to continuously feed new, relevant operational data back into the model retraining process.
So the model keeps learning from the latest information the bots are processing.
Yes, keeping it fresh. Feedback loops, particularly involving human in the loop, HITL, are also highlighted as very valuable.
How does that work?
When the ML model provides a prediction with low confidence, maybe the fraud score is in a gray area, or the document extraction certainty is low, the UiPath workflow can automatically route that specific case to a human expert for review.
Okay.
The human makes the final decision, and crucially, that decision, the ground truth, is fed back into the system as new training data. This helps the model learn from the cases it was unsure about, improving its accuracy over time, especially on edge cases.
So humans act as teachers for the AI when it's uncertain, a continuous learning cycle.
That's the principle. The study also mentions hyperparameter tuning, periodically optimizing the internal settings of the ML algorithm itself for best performance, often facilitated by tools like UiPath AI Center. And ensuring scalability, often via cloud deployment, is part of this too, ensuring the system can handle increasing data volumes without performance degradation.
Making sure it doesn't slow down or break as the workload grows.
Right. Consistent performance is key. And using techniques like cross-validation during the initial training phase helps ensure the model generalizes well to new data from the start, reducing the risk of overfitting, where the model learns the training data too well but performs poorly on unseen data. The study even cites a real-world banking fraud detection example where implementing these continuous improvement strategies significantly boosted the model's F1 score, showing the practical impact.
That really proves evaluation and improvement aren't just academic exercises, they're crucial for maintaining real-world value over time. Okay, let's dive deeper into some of those specific real-world application areas where this integration shines.
Absolutely. Let's start with intelligent document processing, or IDP. We touched on it, but it deserves more detail.
This is the tech that lets automation actually read and make sense of documents, right? A huge deal for many businesses.
A massive deal. Because, as we said, traditional RPA really struggled with the variability and unstructured nature of many business documents, invoices, contracts, purchase orders, emails, claims forms, you name it. IDP leverages ML and AI specifically to tackle this challenge.
Going beyond simple OCR to actual understanding.
Exactly. It's about extracting the relevant data and meaning from these documents, regardless of layout variations. Take invoice processing. An ML-based IDP solution integrated into a UiPath workflow can learn to identify the invoice number, date, vendor name, line items, and total amount, even if they appear in different places on invoices from different suppliers.
It learns the patterns, like an invoice number usually looks like this, or the total is often near the bottom right.
Precisely. It uses techniques often based on deep learning, like convolutional neural networks, CNNs, combined with NLP, to understand both the visual layout and the textual content. This allows for highly accurate data extraction, significantly reducing the need for manual verification.
Saving a ton of manual effort and speeding things up.
Immensely. It lowers processing costs, reduces errors, and also improves document searchability and compliance later on because the key data is extracted accurately up front. Another key IDP application is document classification.
Automatically figuring out what kind of document it is.
Yes. Instead of someone manually sorting incoming documents, this is a contract, this is a support ticket, this is a shipping receipt. An ML model can classify them automatically based on their content and structure. This helps route documents to the correct workflow immediately.
Streamlining the whole intake process.
Exactly. The study also mentions that modern IDP solutions often use enhanced AI-powered OCR that can handle more challenging inputs, like handwritten text, documents in multiple languages, or even distorted or low-quality scans, further expanding the range of documents that can be automated. Integrating IDP into UiPath creates powerful end-to-end automation for document-centric processes.
That really tackles a fundamental bottleneck in so many administrative workflows. What's another key application area?
Predictive workflow optimization. This is about making the automation process itself more intelligent and adaptive.
So not just automating the steps, but optimizing how the steps are executed.
Exactly. Traditional RPA workflows follow a fixed sequence, but ML allows the workflow to become dynamic. By analyzing historical and real-time data about the process itself, ML models can predict potential bottlenecks, forecast workload fluctuations, or identify opportunities for efficiency gains.
And the UiPath bot can then adjust its actions based on these predictions.
That's the idea. A great example is supply chain management. ML models can generate much more accurate demand forecasts than traditional methods. UiPath bots can then use these forecasts to automatically adjust inventory levels, optimize shipping routes, or proactively manage supplier orders to minimize delays and costs.
So the automation is constantly tuning the supply chain based on predicted future needs.
Yes, making it more resilient and efficient. Another area is resource allocation. ML can analyze data on team performance, task complexity, or machine availability to dynamically assign work or allocate resources in the most optimal way.
Like figuring out the best person or machine for the next task based on current conditions.
Exactly. The study mentions manufacturing, where predicting variations in production line efficiency can help dynamically adjust staffing levels or task assignments to maintain overall throughput. ML can also help reduce process delays by identifying likely bottlenecks before they occur and triggering preventative actions, like rerouting tasks or prioritizing specific items.
Smoothing out the workflow proactively.
Yes. The study conceptually includes a table comparing traditional versus ML-based RPA across industries. It really highlights this shift moving from reactive, rule-based execution to proactive, data-driven optimization in areas like banking, healthcare, retail, manufacturing, and more.
That comparison table sounds useful for seeing the before and after picture across different sectors.
It provides a good overview of the enhanced capabilities.
Yeah.
The final major application area detailed is customer service automation.
Right, making chatbots and virtual assistants genuinely helpful.
That's the core goal. ML fundamentally enhances the intelligence, accuracy, and effectiveness of automated customer interactions. We all know the frustration of dealing with basic script-based chatbots that can't handle anything slightly off topic.
They hit a wall very quickly.
Exactly.
Yeah.
ML-driven bots, powered by advanced NLP and often deep learning models, can understand the intent and context of customer queries much better. They can handle variations in language, understand slang or typos, and provide more relevant conversational responses.
More like talking to a knowledgeable assistant than a rigid script.
That's the aim. They improve engagement by analyzing the customer's history and the current conversation to provide personalized help. And crucially, they learn from each interaction, constantly improving their understanding and responses over time. A key advancement here is sentiment analysis.
We touched on this figuring out the customer's emotion.
Yes, using ML to analyze the text or even voice tone to gauge if the customer is happy, frustrated, angry, confused. This allows the bot to tailor its response appropriately.
Like being more empathetic if someone's upset or escalating quickly if needed.
Exactly. The study mentions a telecom provider using sentiment analysis this way, which significantly cut down complaint resolution times and boosted satisfaction. ML also enables much better personalized responses, like recommending specific products in e-commerce based on browsing history and past purchases.
Making the interaction feel more relevant to the individual.
Yes. And another big plus is multilingual support. Training NLP models on data from multiple languages allows bots to provide effective support globally, reducing reliance on human translators for common queries. Integrating these ML capabilities transforms customer service automation from a basic FAQ tool into a sophisticated, efficient, and engaging channel.
It's clear these applications show ML isn't just a small tweak, it's fundamentally changing what automation can achieve, handling tasks that require understanding, prediction, and adaptation.
Absolutely. But, as with any powerful technology, the path to implementation isn't always smooth. There are definite challenges.
Okay, let's pivot to those challenges and limitations. What are the main hurdles businesses encounter, according to the study?
A major one, perhaps the most critical, is dealing with data quality and related model training issues. We keep coming back to data.
Because it's foundational for ML.
It is. The study emphasizes that ML models need large amounts of high-quality, relevant data to learn effectively. But real-world business data is often the opposite. Inconsistent across different systems. Incomplete, full of errors or noise, sometimes outdated.
Getting that data into shape sounds like a big initial investment.
It can be a significant undertaking. Integrating datasets from various sources, ERPs, CRMs, spreadsheets, legacy systems, each with its own format and quirks, requires substantial effort in cleaning, validation, and standardization. The research makes it clear. If your underlying data is poor, your ML model's predictions will be unreliable, regardless of how fancy the algorithm is.
You absolutely have to address the data foundation first. What about bias?
That's another huge issue highlighted under data challenges.
Yeah.
Bias in training data. If the historical data used to train the model reflects existing societal biases, perhaps in past hiring decisions, loan application approvals, or even customer service interactions, the ML model can inadvertently learn and perpetuate those biases.
So the AI could end up making discriminatory decisions without anyone intending it to.
Precisely. The study gives examples like credit risk models, potentially discriminating against certain demographic groups if trained on biased historical data, or hiring algorithms showing bias based on gender or ethnicity reflected in past hiring patterns. This is a massive ethical and legal concern.
How do companies mitigate that risk?
It requires a very conscious effort. Implementing robust data governance practices, carefully validating data sources, using techniques to detect and mitigate bias in both data and models, ensuring diverse representation in training datasets where appropriate, and potentially using techniques like data augmentation or synthetic data generation to address imbalances. It's an active area of research and practice.
Okay, so data quality and bias are huge. What's another challenge?
Model interpretability and transparency. Especially with more complex models like deep neural networks, they can function as black boxes.
Meaning it's hard to understand why they make a particular prediction.
Exactly. You feed data in, you get an answer out, but the internal reasoning process can be incredibly complex and opaque. This lack of transparency can be a major barrier.
Why is that such a problem?
For several reasons. It hinders trust. Business users might be reluctant to rely on decisions they don't understand. It makes debugging difficult if the model starts making mistakes. And critically, it poses significant challenges for compliance.
Because regulations might require you to explain automated decisions.
Yes, particularly in regulated industries like finance or healthcare, or for decisions significantly impacting individuals like loan approvals, hiring, insurance. Regulations like GDPR or the upcoming AI Act increasingly demand the ability to explain the logic behind automated decisions. If your model is a black box, fulfilling that requirement is tough.
So how are organizations tackling this black box problem?
This is where the field of explainable AI, or XAI, comes in, as the study discusses. The goal is to develop techniques that can shed light on how these complex models reach their conclusions.
Making them less opaque.
Trying to? Yes. Some approaches involve using inherently more interpretable models, like simpler decision trees or linear models, where possible, though these might sacrifice some predictive power. For complex models, techniques like Ache and Lime are becoming popular. They work by analyzing how changes in input features affect the model's output, essentially providing insights into which factors were most influential for a specific prediction.
So tools that try to approximate or visualize the model's reasoning?
That's the idea. They provide local explanations why this specific decision was made, or global explanations, general drivers of the model's behavior. It's still an evolving field, but crucial for building trust and meeting regulatory demands.
That makes sense. A third major challenge.
Integration challenges with existing enterprise systems. This is often a very practical nuts and bolts barrier. Many organizations, especially larger established ones, rely on legacy IT infrastructure.
Older systems that weren't built with AI or modern APIs in mind?
Exactly. These older systems often lack the flexibility needed to easily integrate with modern, often cloud-based AI and automation platforms like UiPath. The study conceptually refers to a figure illustrating key barriers, and this integration complexity is right up there.
What kind of specific integration issues arise?
Things like data interoperability, trying to extract data from legacy systems that might use proprietary formats or lack modern APIs. There are also often significant security and compliance concerns when trying to connect sensitive data residing in on-premise legacy systems with external cloud-based AI services. Bridging that gap securely can be complex.
So getting the old and new systems to talk to each other reliably and securely.
That's the core issue. Strategies the study mentions for overcoming this include prioritizing API-based integration wherever possible, even building custom APIs for legacy systems if needed. Using hybrid cloud solutions can also help, allowing organizations to keep sensitive data on-premise while leveraging cloud AI services for processing. And containerization technologies like Docker and Kubernetes can make it easier to package and deploy ML models flexibly across different infrastructures, improving compatibility and scalability.
So employing modern IT architecture strategies to bridge the gap between legacy systems and new AI capabilities.
Yes, making that connection feasible and manageable.
Okay, we've covered the significant hurdles, data issues, the black box problem, and integration headaches. Now, what about strategies the study recommends for actively enhancing ML-driven RPA, building on what works?
The research outlines several key strategies for maximizing the value and effectiveness. First, actively leveraging cloud-based AI services.
Going beyond just basic cloud hosting, using the specialized AI platforms from providers like Microsoft Azure, Google Cloud, or AWS.
Exactly. These platforms offer much more than just scalable computing. They provide dedicated environments and tools specifically designed for the entire ML lifecycle: data preparation, model training, deployment, monitoring, and management.
What are the specific advantages of using these specialized cloud AI services?
The study highlights several. Scalability is a big one. You get access to virtually unlimited elastic computing power, which is crucial for training models on large data sets or handling real-time prediction workloads, like fraud detection needing millisecond responses.
Pay-as-you-go power when you need it.
Right. They also offer managed services. This means the cloud provider handles a lot of the underlying infrastructure maintenance, patching, and optimization, reducing the operational burden on the organization's IT team.
Freeing up internal teams to focus on the models and applications.
Yes. These platforms also often facilitate better collaboration, allowing data scientists, developers, and business analysts across an organization to work together on AI projects more easily. And importantly, they usually provide built-in capabilities for automated retraining and model versioning, making it easier to keep models up to date and track their performance over time, linking back to that continuous improvement point.
So the cloud platforms streamline the whole ML operations process, MLOps.
They're a massive enabler for efficient and scalable MLOps, yes. The second key strategy discussed is doubling down on explainable AI, XAI, for business process automation.
We talked about the lack of interpretability being a challenge, so making explainability a strategic priority is key.
Absolutely. The study positions XAI not just as a technical fix, but as a strategic imperative for building trust, ensuring adoption, and meeting compliance needs. Actively incorporating XAI techniques like ESHEP or LIME to generate insights into model predictions should be part of the development process, not an afterthought.
And this connects directly back to the regulatory landscape.
Directly. The study emphasizes that regulations like GDPR and the AI Act are making explainability a requirement, not a nice-to-have, especially for automated decisions with significant impact. Businesses operating in sectors like finance, healthcare, or HR must be prepared to justify why their AI systems made certain decisions. The conceptual table 2 in the study details these sector-specific compliance needs, underscoring the demand for transparency in loan decisions, ethical data use in healthcare, fairness in retail personalization, and accountability in public sector automation.
So proactively building an explainability is crucial for future-proofing your AI automation against regulatory scrutiny.
It's becoming essential for responsible and sustainable deployment. The third major strategic area encompasses security and ethical considerations. These need to be woven into the entire lifecycle.
Going beyond just technical performance to ensure the automation is safe and fair.
Exactly. Data privacy and system integrity are paramount. The study points out specific security risks related to ML, such as adversarial attacks.
Where someone tries to trick the AI model.
Yes. By subtly manipulating the input data to cause the model to make an incorrect prediction, perhaps fooling a fraud detection system or a security scanner. Mitigation strategies include robust authentication, end-to-end encryption of data pipelines, input validation, and potentially using ML itself for anomaly detection to spot suspicious input patterns.
Using AI to defend AI, in a sense.
Sometimes, yes. Beyond direct security threats, establishing and adhering to clear ethical AI guidelines is crucial for responsible deployment.
This brings us back to bias and fairness again.
It's a core component. Actively working to identify and mitigate bias in training data and models is an ethical necessity to prevent discriminatory outcomes in areas like hiring, credit scoring, or even customer service prioritization. The study stresses the need for bias detection frameworks, regular audits, and promoting diversity in training data.
Ensuring the automation reflects fairness principle.
Yes. And another key ethical consideration, strongly recommended by the study, is maintaining appropriate human oversight, the human-in-the-loop, HITL model we discussed.
Especially for high-stakes decisions.
Especially then, where an incorrect AI prediction could have significant negative consequences in healthcare, legal settings, major financial decisions. Having a human review and validate the AI's output before a final, critical action is taken is often essential. It provides a safety net and maintains accountability.
The AI assists the human, but the human retains final judgment in critical scenarios.
That's the responsible approach in many contexts. The overarching goal of these strategies, leveraging cloud, prioritizing XAI, embedding security and ethics, is to build AI automation systems that are not only effective, but also trustworthy, secure, fair, and aligned with both regulations and societal values.
It's a holistic approach, balancing technological power with responsibility. Okay, looking forward now, what does this study suggest about the future trends in this space? Where is ML-driven automation heading?
A major trajectory identified is the evolution towards increasingly autonomous processes.
Moving beyond just assisting humans to bots that can manage processes more independently.
That's the direction. We're talking about self-learning automation bots that can adapt their behavior and optimize processes over time using techniques like ML and reinforcement learning with less direct human programming or intervention. They continuously refine their decision-making based on real-time data and outcomes.
Automation that truly learns and improves on its own.
Getting closer to that, yes. Emerging trends mentioned include bots using unsupervised learning to proactively identify inefficiencies or anomalies in workflows and suggest optimizations without being explicitly told what to look for. Think of a bot in finance flagging a recurring process bottleneck on its own.
The bot itself suggesting process improvements.
Exactly. Continuous improvement becomes more automated, with adaptive learning algorithms enabling models to retrain themselves on live data, allowing, for instance, supply chain automation to dynamically adjust inventory strategies based on real-time demand shifts and disruptions.
Making the automation constantly self-tuning.
Yes. And further integration of more sophisticated NLP and computer vision will allow these autonomous systems to handle even more complex unstructured data sources, understanding nuanced emails, interpreting complex images or videos with greater accuracy, powering things like truly intelligent document processing end-to-end. The study conceptually includes a figure 3 depicting this roadmap towards more cognitive, autonomous automation.
This sounds very much like the concept of hyperautomation we hear about automating more and more complex end-to-end processes.
That's precisely the path the study describes. It's moving towards a convergence of AI, ML, and process automation, where bots can handle increasingly sophisticated workflows with minimal human oversight, essentially creating self-optimizing business processes.
What other future trends does the research highlight?
Hybrid AI models are seen as increasingly important. This means combining the strengths of different AI techniques within a single solution.
Not just using ML alone, but mixing it with NLP, computer vision, etc.
Exactly. Creating more powerful, synergistic AI systems. For example, a customer service virtual assistant might use NLP to understand the conversation, ML for predictive analytics to anticipate the customer's underlying need, and maybe even reinforcement learning to optimize the dialogue flow for maximum efficiency and satisfaction.
Blending capabilities for a more holistic solution.
Yes. Or in industries dealing with lots of documents and images, combining computer vision for seeing the document image with ML for understanding and classifying the content can streamline incredibly complex tasks, like analyzing medical images or processing intricate legal contracts. RL-enabled bots could learn optimal real-time strategies for complex logistical challenges, like dynamically rerouting delivery vehicles based on traffic, weather, and new pickup requests.
So composing different AI skills together to tackle multifaceted real-world problems.
Leading to more resilient, adaptable, and intelligent automation solutions. Finally, the study revisits the ethical and societal implications, projecting them into this future context.
As automation gets more powerful and autonomous, these concerns become even more amplified, I imagine.
They absolutely do. The study reiterates that addressing AI bias and fairness will remain critically important, perhaps even more so, as automation becomes embedded in core societal functions. The need for rigorous bias audits, diverse data sets, continuous monitoring for unintended consequences, and transparency will only intensify.
And the role of regulation.
Regulatory bodies worldwide, like those behind the EU AI Act or evolving GDPR interpretations, will continue to shape the landscape, reinforcing the requirements for explainability, accountability, and risk management in AI systems.
And human oversight remains crucial.
The study reemphasizes the importance of human-in-the-loop models, particularly for high-stakes decisions, ensuring that increasing automation doesn't lead to a loss of human control or accountability where it matters most. The overarching goal, looking forward, must be to develop and deploy these advanced automation frameworks in a way that is fundamentally trustworthy and responsible, safeguarding societal interests alongside driving business value. The study includes a final conceptual table, Table 3, summarizing the broad business benefits driving this adoption: enhanced efficiency, predictive capabilities, improved accuracy, scalability, cost reduction, better decision-making, adaptive learning, advanced customer service, and robust compliance risk mitigation.
That table sounds like a good snapshot of the compelling why behind this whole trend.
It provides a comprehensive view of the value proposition, yes.
Well, it's been an incredibly thorough deep dive, really unpacking the findings of that study on ML and UiPath integration. Let's try to summarize the absolute key takeaways.
Okay, so the core message from this research is clear. Integrating machine learning with automation platforms like UiPath is genuinely transformative. It's moving business process automation far beyond simple rule-following bots.
Into the realm of intelligent, predictive, and adaptive systems.
Exactly. And this shift delivers significant measurable improvements across the board, boosting efficiency, enhancing accuracy, enabling better decisions, and reducing costs in a wide variety of business functions.
We saw concrete examples, from smarter document processing and proactive workflow optimization to much more capable customer service bots. ML empowers RPA to handle real complexity.
Delivering tangible business value that wasn't possible before. And while we discussed the real challenges, data quality nightmares, the black box issue of interpretability, and the headaches of integrating with legacy systems.
The study also points to clear strategies for overcoming them.
Right. Leveraging cloud AI platforms effectively, making explainability, XAI, a priority, careful planning for integration, and continuous monitoring and improvement are key tactics highlighted.
So if a business is considering embarking on this journey, what are the top-level recommendations coming out of this research?
The study really emphasizes a strategic and prepared approach. First, focus intensely on data readiness. Getting your data house in order is step 0, and carefully select the right ML models for the specific problems you're trying to solve. Second, adopt scalable deployment strategies, often involving cloud or hybrid cloud architectures. Third, prioritize continuous model improvement, and explainability models need ongoing monitoring, retraining, and efforts to make their decisions transparent.
Don't just deploy and forget.
Absolutely not. And finally, establish strong governance frameworks from the start, covering security, ethical considerations, bias mitigation, and regulatory compliance.
Good data, smart deployment, ongoing improvement, and transparency, all within a strong governance and ethics framework.
That's the blueprint for success outlined in this research.
This has been incredibly illuminating. It paints a vivid picture of where intelligent automation is today and where it's rapidly heading. And it definitely leaves us with a final provocative thought to chew on.
It does. As we've discussed this shift towards more intelligent, adaptive, maybe even autonomous processes, it's worth considering how this might not just change what tasks get automated.
But could fundamentally alter the very nature of work itself.
Exactly. The skills that will be most valuable in the future, the way humans collaborate with these increasingly intelligent systems, the structure of organizations, it all potentially changes. Definitely something for all of us to ponder as these powerful technologies continue to evolve at pace.